Hello class. Today is February 10th, 2015. And basically you guys are having a sub right now because I had to go to one of those SRG meetings. So we're going to do a couple of things a little bit, different. You're going to still go in order of my other classes, except with a few twists. So your schedule is going to look something like what's on the board. So let's just go in the order, okay? We're going to start off with page 51 and 52 in your notebook, all right? If you don't have pages 51 or 52, I will have them on top of my counter, and they will be labeled. So that means if you were gone that day, I would grab it, okay? 51 is going to look a lot like this. This is what 51 looks like. Now, I want you to do this all by yourself. The sub does not need to come around and help you with this. I have not actually done anything with you on this, but truly, if you just read what it says here, then it should be very simple for you to do. Like for you to do this part and this part, okay? I just want to see what you can do without help, all right? So I want you to do this. I'm going to give you 5 minutes to do this part here. And then after you're done with that, I also want you to do 52, page 52. So make sure you turn your books right here and circle these problems. They're also written on the board. I just want you to do 1, 4, and 7. Okay? And if you are feeling adventurous, you can do number 2. Number 2 is going to be a lot like this page right here. So whatever you did here, then you're going to do it there. Okay? I'm going to pause it. When I add this page in with that page, I'm going to give you 10 minutes. So I'm going to ask the sub to just pause this video, look at the clock, and give you 10 minutes, and then press play. Okay? And you guys, please help the sub out if they need it. And if the sub, I'm asking the sub, I already talked to the sub about this, but I'm asking them to write down the names of anybody who was helpful, because I will be happy to shower you with BE's cards. Okay? Good. Alright, so let's go ahead and do page 1. Alright, not page 1, 51. Okay, so this is really easy. If you were just looking at it right here and you did exactly what it said, then you should not have any issues, okay? This is showing you how to add resistance in a parallel circuit. Up until now, we've only been talking about series circuit, and here's an example of a series circuit. A series circuit looks like this. See? Alright. There you go. And it's a series circuit, and it's series because it only travels in one path. So that means things like electrons only move around in one area. It doesn't have multiple paths to go down. All right. Unlike over here, if you shut down this area right here, then electrons can still go down these two branches right here. So that's the difference. All right, so now you're going to figure out how to calculate a a parallel circuit. All right, if you did this right, you should have put, you're just looking at what it says over here, and you're just going to copy these numbers down underneath these blanks. So 10, 22, and 47. So I'm going to write that down. 10, 22, 47. And then what you're going to do is you're going to change these into decimals. So 1 divided by 10 equals 0.1. 1 divided by 22 equals 0.04. And 1 divided by 47 equals 0.16. Now you can add, because adding decimals is so much nicer than adding fractions, in my opinion. I think I did something wrong. Oops. Doesn't equal 0.16 equals 0.02. There you go. And then you add all these together, you should get 0.16. All right? Now, you don't stop there. You take this answer and you stick it in here, 0.16. And you divide it. So 1 divided by 0.16, you should have got 6.25. And remember, always remember to put your units. Okay? If you got that, you're super awesome. Okay, let's do the next one. All right, so you got 133, 560. Alright, so 1 divided by 100 is 0.01, and 1 divided by 33 is 0.03, and 1 divided by 560 is 0.001. Alright, then you add all those together, you should get 0.041. Sounds good. And then you take this answer and you stick it over here. 0.041 divided by 1, or 1 divided by 0.041. You should get 24.39 ohms. Okay? I don't care if you said 24.4 or 24. I mean, you should say 24.4, not 24.3, but as long as you are in this realm, I'm good. See, that wasn't so bad. Not at all. Okay, so if you were gone, make sure this is glued in on page 52. So now we're going to go on to page 50. Sorry, this should be glued on page 51. Okay, but now we're going to go to page 52. Okay, if you remember your notes, we're calculating it says right here, for number 1, 3 resistors with values of 3, 6, and 12 are connected in series. What is the equivalent resistance? I'm going to just go through the answers real quick. Okay, I'm just going to write them down. And the answers that I got was, what am I doing? Okay, I'm just going to write ohms. 21 ohms. All right. For 4, I got wrong one. I got 53 ohms. Is that what you got? And then for number 4, I got 12 ohms. That's it. All right, and I'll just show you how to do one of these. So remember, to calculate in a series being the key, you are going to do R1 plus R2 plus, so on. So you're adding these. So it'd be 3 plus 6 plus 12 equals, and you should have got 21 ohms. Okay? Same goes for down here. You're basically adding up all of these. Okay. All right. Now, for my more awesome and adventurous people who actually did number 2, I'm going to solve this one. I'm going to show you how you do it. So it says 3 resistors with values of 4, 6, and 12 are connected in parallel key. So you need to be making sure you pay attention to if it says in parallel or in series. If it says in parallel, you're going to be using a different formula, which is the R1, 1 over R1 plus 1 over R2. All right, basically what you see over here in this one, right there. Okay, so now I'm going to go ahead and do that. So 1 over 4 plus 1 over 6 plus 1 over 12. The next thing you do is you change all of these into decimals. So that would be 0.25 plus 0.16 plus 0.083. You add all those together, you get, here you go, 0.493. And then you put that over 1. You divide that. 1 divided by 0.493. You should have gotten 2.03 ohms. Okay? Simple. Super simple. Okay, so now what I need you to do is I need you to turn to page 50 in your notebooks, okay? You should notice, sorry, I don't have enough room. You should notice that in your notebooks, that would be your notes. It should be 14.2 notes. You are about to do those notes out of the physics book. So make sure you got a blue physics book. If you don't have one, go get one. You know where they are. They're on the bookshelf to the right, by the lab side of the classroom. So don't play any games. Anyhow, here's the deal. Usually, you guys would be playing the team games and have an opportunity to win BE's cards, but I had to go to this meeting. My other classes got a chance to do this, so I will make a deal with you, okay? If you get these done, then basically when I come back, I will just look at your notes. I will stamp them. Those of you who got it complete will get 2 BE's cards each, okay? Because that's basically what you would have gotten if you were playing the game, unless you were, of course, the winners. All right. Also, the class that does the absolute best, is the most best behaved class between you, and all you really are going through is 2 different classes. So you're going up against 3rd and 4th block. So the class that the sub feels was the best behaved will be entered into a drawing for a phone pass day, a free phone pass day. Okay. Now, the sub has to actually like you, because if she doesn't like neither of you guys, then she could just say neither. Or she could say, I liked this block the most. So, let's see what's up. All right. Have a good day. Talk to you all later. Oh, there's one more thing I forgot. You're supposed to have this paper, so make sure you have this paper out. I'm going to give you guys 10 minutes to do this paper. This is all before you actually get the notes. So we're going to do this, and then you're going to do notes. Okay? My bad. Oopsie. Okay. So, here we go. I'm going to just have you pause this video until you're ready. Okay. Go ahead and pause now. Okay, so this is how you would draw a parallel circuit that includes four resistors, 3 switches, and 1 battery. Okay, so as you see here, here's my battery, and here's my switch. Apparently this is open. So 1, 2, 1, 2, 3, okay? And then these are my 4 resistors. All right, I need to point out, these resistors look very easy. They're simple. There you go. 3 ridges is all it takes to make 1 resistor. For some odd reason, when I was looking at my, what do you call those things, assessments, I noticed that if I said you had a 6 ohm resistor, then I noticed people doing stuff like this, 1, 2, 3, 4, 5, 6. Or if it had 12 ohms, and you would like actually count out 12, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't do that, okay? It's just 3. 1, 2, 3. That's it. And then you just continue on with your line. Okay. So that was just that one thing. And then the other is, if I see you drawing something and it looks kind of like, you know, like a box, like this, for instance, this is not a parallel circuit. This is a series. And why is it a series? A series and not a parallel? This next question actually will answer it for you. It says, how many paths will the electricity flow? Well, let's check it out, shall we? Here's the battery. It goes around, and we're done. 1 path. So it only flows once. 1 time around. Anytime it only flows 1 time around, that would make it a series circuit. If it can flow multiple times around, then it is a parallel. Here's an example. So you got your circuits. This thing can go several ways to get back to the battery. It can go this way. There's 1. It can go this way. There's 2. It can go this way. There's 3. Okay. So this thing can actually go 3 different ways. All right. Same with this one over here. This one, it can travel. So it goes down. Here's 1. It can do this. 2, 3, 4. So this has 4 different ways it can travel. This makes it a parallel path. A parallel series, I mean. Alright, so let's, I already answered this one. This 1, and we know this one is a series circuit because it only has 1 path. So now down here it says, what would happen in the circuit if switch 4 was open? So here is switch 4. If this was open, then A would not work. B would, because, here we go. It can go through this way, This one has a lot of different ways it could travel. But, yeah, so if 4 was open, then B won't work. Okay. It says here, if switch 1 was open and all others were closed, so here's switch 1, then you would get no power because that is a part of a series circuit. And let me show you. So you have your battery. It can go through all of these ways, including these branches here, and come back out this way, make it all the way around, and then it will get stopped right here, so it never actually reaches it back to the battery, which means you get no power. If B broke, then it would still be able to travel through A and C. So A and C would work. Okay. How many paths can current flow? Well, let's count. Let me just erase this. I got a lot going on over here. How many paths? And you know what? Some of y'all might be confused. I was talking about this one up here. So let's count how many goes this one. If you answered the one down there, then that's okay. I'll count that for you too. So it can go this way. Here's 1 way. Here's another way. 2. Here's another way. 3. Okay. 4. 5. I think I got backed up. Let me count. There's about 9 different ways it can flow through here. So you have it, yeah, 9 different ways. So there you go. Here's 1. Here's 2. Here's 3. Okay. And then you do the same thing again. Here's 4. Here's 5. And here's 6. Here's 7. Here's 8. And here's 9. So 9 different ways it can flow. Here's the last two, and these two questions are going to this one right here. So it says, which lights work because switch 1 is open? Here's switch 1. The ones that actually will still open would be A, C, D, and E, okay? Because it can still travel through all of these ones. And down here, because switch 2 is open, A, B, C, and D still work. All right, now that I'm done with that, you can go ahead and get started on your notes, okay? Turn your books to page 323, just to help you get started. All right, bye-bye.